Okay, today we're going to look at graphs of other trig functions. So now we're going to look at cosecant and secant. Cosecant is the reciprocal of sine. So what you're going to do is graph the sine function the same way we did before. Make sure you identify your amplitude, period, phase shift, and vertical shift. And then what happens is it says all x-intercepts become vertical asymptotes. So everywhere your graph hits the x-axis, that becomes a vertical asymptote, because what happens is when you do the reciprocal of 0, it's undefined. So those points where x is 0, or excuse me, your y is 0, then when you do the reciprocal, it's undefined. So that's why we have vertical asymptotes there. Same thing with the cosine graph or secant. Secant is the reciprocal of cosine. So everywhere your graph hit the or your y coordinate was 0, when you do the reciprocal, it's undefined. And if you look on your unit circle, those are the regions where secant is undefined. And so if you notice, when I graphed the original, I did it using dashed lines because we really don't see that graph. We're just using that as a model. And so what you're going to do, it says all maximum points become minimums. So you see this? This has now become a minimum point, and you just do the reciprocal, and you flip it. And then all your minimum points become maximum. So here, and don't touch the asymptotes, and that would be cosecant. Same thing with cosine. This is actually a maximum, so I'm just going to flip it like this. And that's your minimum. And then I'll flip this one. And so what happens is we actually graph more than one period so you can see how, see a fuller picture of your graph. And so when you check your answers in the back, you're not going to see the sine and the cosine graph because those are like our parent graphs. So that's why I'm making the lines dashed. It may be easier if you use two different colors so that you won't get confused on which graph is what. So we're going to just try a couple to make sure you get it. Okay, here's our first graph. We'll start off with cosecant. Remember, cosecant is the reciprocal of sine. So we're actually going to graph the sine function. So I still identify A, B, C, and D. So A is 2, B is 1. Remember, it's the number in front of X. C is 0, D is 0. And we find our characteristics the same way. My amplitude is the absolute value of A. My period is 2 pi over B, which is 2 pi. My phase shift, x equals 0. My vertical shift, y equals 0. Now, the difference is we're going to be doing 2 periods. So my highest is 2, my lowest is -2. We're starting at 0, and you're going to take your period and you divide it by 4, which is pi over 2. So we're starting at 0. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, And that's one period. That's 1, 2, 3, 4, 5. What happens is the this fifth tick mark becomes the first one in the next period. So you're going to keep going again. I'll do this period in pink so you can see the difference. 5 pi over 2, 6 pi over 2, 7 pi over 2, and then 8 pi over 2. And this represents your second period. So all together you should have 1, 2, 3, 4, 5, 6, 7, 8, 9 tick marks for 2 periods. So you do your sine graph. Remember, sine starts at 0 to your max, 0 to your min, back to 0. And then you start the cycle again. To your max, 0 to your min, and back to 0. Remember, everywhere it hit the x-axis becomes an asymptote because that's where it's going to be undefined. And what I do is, when I do my sine, I use dash lines because remember we can't really see that. And then I flip my minimum and maximum. And when you get really good, you don't have to show the original if you know where to flip it. And then that represents 2 periods of cosecant. Okay, and then we'll try a secant graph. Okay, you're going to do the same thing. Identify A, which is 1. B, this is tricky because there's an actual 1 in front of that X. So that's actually 1/2. And C, we don't have. And D. So my amplitude is the absolute value of 1, which is 1. My period is 2 pi divided by 1/2, which is the same thing as 2 pi times the reciprocal. And that would be 4 pi. My phase shift, I don't have one yet. And my vertical shift is y equals 0. So we're doing 2 periods again. So I'm going to take my period and divide by 4 to get my tick marks. So I'm adding 1 pi each time. So this will make it a little easier. So 1 pi, 2 pi, 3 pi, 4 pi. That's 1 period. So you do another period. 5 pi, 6 pi, 7 pi, 8 pi. That's your 2 periods. So it repeats after every 4 pi. So that's what that period means. And then this is cosine. So remember, cosine starts at your highest or your max, then 0, then your min, then 0, then back at your max, then 0, then min, then 0, then back at your max. Remember, everywhere it hit the x-axis, it becomes undefined for secant. Undefined, undefined, undefined. And if you need to, you can draw the cosine graph first. And then we're just going to do the reciprocal. Now, you may notice that the book goes over into the left in your answer so you can see that full wave. You don't have to, but if you want to, you can. So you may see it goes a little past 8 pi, so you can actually see how the curve is going to look. But I'm fine if you don't. And then that's secant. Okay, let's see what happens when we have a phase shift. So A is 1, B is 1, C, remember, is opposite, that's pi over 2, and D is 0. So my amp, absolute value 1, which is 1. My period is 2 pi over B, which is still 2 pi. My phase shift is x equals C over B, which is pi over 2. And my vertical shift is y equals 0. My max is 1, min is negative 1. So our first starting tick mark is pi over 2. So you take your period, which is 2 pi, and you divide it by 4, which is pi over 2. So that's what we're adding each time. You want to make sure your denominators are the same because that's the only way you can add it. So that's 1 pi over 2 plus another pi over 2 would be 2 pi over 2, which is pi. And then 3 pi over 2. And then 4 pi over 2. And then 5 pi over 2. That's one period. Then you keep going. 6 pi over 2. 7 pi over 2. 8 pi over 2. Remember, you got to have 9. 1, 2, 3, 4, 5, 6, 7, 8. One more. 9 pi over 2. And there we are. And this, remember, we're actually graphing sine. So it starts here, here. You just follow your pattern. That's one period. And then you loop it back around. It's like a circle, it never ends. And then you draw your vertical asymptotes, because that's where cosecant is undefined. And if you need to, you can draw your sine graph. And then you flip them. And there's your phase shift. we can see the same with secant, so I'll do a secant. So A now is 2, B is 1, C, remember, is opposite, and D is 0. So my amp is the absolute value of 2, which is 2. My period is still 2 pi over B, which is 2 pi. My phase shift is X equals C over B, which is still negative pi over 2. And my vertical shift is Y equals 0. Alright, I'm just sticking my y-axis here. I'm not sure where how my tape marks are. So we better do our period divided by 4, which is pi over 2. So we're starting at negative pi over 2. And sometimes you're going to have to move your y-axis if you don't have enough room. But we're adding pi over 2 each time. So if you do a negative plus a positive, my second tick mark is going to be at 0. And then I'm just going to keep adding pi over 2. So that's one period. And I don't know if I'm going to have enough room, because I made my increments so large. So that's 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. Let's make sure we have 9. 7, 8, 9. Okay, so we're good. 2 is my max, negative 2 is my min. So remember, this is cosine. And then you draw your vertical asymptotes, because that's where secant is undefined. And if you need to, you can draw the cosine graph. Remember, that's optional. And then we're going to flip it. Remember, the ones on the ends, you can make them full curves, or you can do the half ones like I did. And then that's it. And we'll try a vertical shift so you can see how that looks as well. So I'll end our lesson with one of everything. I'll even put a negative so we can see what happens. So my A is negative 1, B is 2, C is pi over 2, remember it's opposite, and D is 1. So my amp is the absolute value of negative 1, which is 1. My period is 2 pi over 2, which is pi. My phase shift is X equals C over B. the same thing as pi over 2 times 1/2, which is pi over 4. And my vertical shift is y equals 1. That means all my points are going to move up 1. Okay, our first starting point is pi over 4. And we got to take our period and divide it by 4. Oh, good. Our denominators are the same. So you're going to keep adding 1 pi over 4. This is 2 pi over 4. 3 pi over 4. 4 pi over 4. 5 pi over 4 will represent 1 period. Then you do it again. 6 pi over 4, I'm going to reduce. 7 pi over 4. 8 pi over 4. And 9 pi over 4. Make sure you have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is secant. A is negative. So we're going to remember, flip. I went too high. And then I do my asymptotes. And notice the order I'm doing everything. And now I'm going to shift my points that remain up 1. So now this one would be here, 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 and here. And the ones that are on the asymptote you don't have to worry about because they're undefined. So now, and remember, if you have to draw the sine curve so you'll know how it looks, then you can. And if you don't need to, then that's fine. So this one will still be a maximum now. This will be a minimum, a maximum, and a minimum. And there is your cosecant graph that was negative. And same thing with secant. If it's negative, your U will be upside down. And that's it.